In this video, I will explain how to check normality for scale data and the Likert scale data using SPSS. Before designing the statistical tool, first we have to check our data, whether the data is normally distributed or not. If the data is normally distributed, we can use any one of the parametric tests like t-test, ANOVA, correlation, regression. If the data is not normally distributed, we have to move towards non-parametric test. So usually normality is applicable for scale data. So what is scale data? If we are collecting data without giving any option, income, age, marks, sales amount, some example here I gave. At the time in social science research, we are oftenly used Likert scale data for converting quality data into quantity. That means 5-point scale data, strongly agree to strongly disagree. Usually we give 5 points to strongly agree, 1 points to strongly disagree. If we want to check normality for Likert scale data, first we have to combine our Likert scale data. For example, if I ask multiple questions for single aspect, if I want to know the factors affecting brand preference, so this is one concept, but 3 or 4 questions may be asked related with this concept. We can combine these 4 or 3 questions. So after that we can check normality. So sometimes we can use mean value for added value. If I have added 4 variables, I can take mean for checking normality. So composite variable is treated as scale data. Now if a single Likert scale item is used directly in parametric test without forming a composite score. So actually we have used Likert scale data for t-test, independent sample t-test, lot of parametric test we have used Likert scale data, but the basic assumption is we have to check normality. By using Likert scale data we can't check normality because it measured in ordinal scale. It consists only 5 options. It is a categorical data. We can't find normality for this data. So at that time what we have to do? So just you have to specify the central limit theorem. So in this in social science research we can use ordinal data as interval data for applying parametric test. One more important assumption is if our sample size is more than 30, our data is normally distributed. This is the main assumption of normality. Just take this assumption, central limit theorem assumption for your thesis work. Applicable for testing normality, here I have specified 3 methods which are the best, which are we can easily get normality result. So even it is accepted for thesis and journal articles. Right, we can easily understand what is the acceptable range of skewness and kurtosis. So the acceptable range should be between -2 and +2. If our sample size is more than 300, at that time if you got kurtosis more than 2, so we can take -2 and +2 are the acceptable range. Anyway, our skewness and kurtosis values near to 0 for getting better normality. This is the path we have to take whether the data is normally distributed or not. First, for doing skewness and kurtosis, we have to choose this path. Analyze, select descriptive from descriptive statistic, move the variable which one you want to check skewness and kurtosis. Click option button. In this box we have to click skewness and kurtosis checkbox in addition to mean standard deviation. Give continue and OK. So look at this table. We got somewhat high skewness and kurtosis value. It means we have some outliers in the data. So first we have to find out the outliers. After removing the outliers, once again we have to do the same analysis. So click analyze. For finding outliers, I have to select explore from descriptive statistics. Move the variable which one you want to check the outliers. From that, click statistics. Checkbox of outlier you have to click, then give continue. Okay. And this is the outlier, that is first response is outlier. So that person gave somewhat different answer compared with others. So look at here, the two respondents give 5800 value, other respondent value is somewhat different from this value. So this is the outlier. I am going to remove the outlier from data set. For that, click first response, right click it and give clear option. So once again I am going to do Q-ness and kurtosis analysis, give OK. So now with the kurtosis value we got 0.251 and minus 0.710. If our value is close to 0, it is better for normality. Anyway, we got acceptable range of skewness and kurtosis. Okay, let us see the second method. By using graph, also we can check the normality for single variable. So we have to combine these variable or find a total or find average for this variable. For that I have to click transform compute variable. So here first I have to give the target variable name, that is customer friendly approach. That's why I gave the name CF mean. So here you have to do the analysis by using this last. So I got average of customer friendly approach concept. So let us see histogram for this variable. We can use graph for checking histogram. So instead of that, this is the simple way for histogram. Just analyze, click descriptive frequency analysis. So move the variable which one you want to draw in histogram. So move the CF mean, click chart. So click histogram along with the show normal curve on histogram. Give continue. Actually we have to uncheck this box because we don't need any percentage analysis, we need only histogram. Give OK. So we got the bell shaped curve. So this data is normally distributed. So let us see the third method, Q plots. For that we have to use this pathway. So click analyze, descriptive statistics, explore. I have to move the variable from left to right, which one I want to check normality. Click plots. So in these plots I have to check this box, normality plots with the test. Continue. So this is the Q plots. In this line dots appear near to the line, hence the data is normally distributed. So if our data is not normally distributed, just we have to follow non-parametric test. If we want to use independent t-test, use a Mann-Whitney equality test is equal to ANOVA. So we have equal test in non-parametric also, Q-ness and kurtosis instead of Kolmogorov. Because when we are using Kolmogorov, it is a very sensitive analysis. So most of the time we can't get normality. So this is the test. Q-ness and kurtosis, histogram, Q plots are appropriate test for checking normality.